So in Unit 8, we're going to begin to look at the last two types of functions that we'll study in Foundations 30. The first type will be exponential functions, and as we get later in the unit, we will look at a set of functions called logarithmic functions. Every exponential function has a base form of y equals a times b to the power of x. A and b will be numbers. X will be the variable that it is, which is an x. Sometimes we will have a coefficient of a, sometimes we won't. And that coefficient of a will dictate some pieces about the shape and the characteristics of this graph. Oftentimes it'll be the base b that we're looking at as well. But we have four exponential functions on this page. I've just split it so that they're easier to see. You can see the bottom half here. And we're going to be looking at the graph to determine the characteristics of these functions. So with this first one, f of x equals 10 to the power of x. The number of x-intercepts, the number of times that this graph crosses the x-axis, is actually 0. It does not actually cross the x-axis. The x-axis actually acts as an asymptote to that graph. The y-intercept, while there is only a single y-intercept, I'm not concerned with how many. I'm concerned with the actual location. And it's difficult to see based on the scale of the graph, but the y-intercept for this graph is at 1. The end behavior is which quadrant this graph begins in, which quadrant it ends in as we go left to right. So on the left side of this graph, it starts in quadrant 2, and it ends in quadrant 1. The domain, and I'm just going to write this off to the side, is all real numbers. Because the domain of a function is where it can exist horizontally, it can go all the way from negative infinity at the far left to positive infinity at the right. Now, while it does look at the end of the graph like it is approaching a vertical line, it does not. It does continue to move to the right, albeit it moves higher much faster than it moves horizontally. The range of this function is the y values, or the vertical values this function can have. This would be anything where y is greater than 0, and it will not be equal to 0 because of the asymptote. Looking at the second function, g of x equals 2 times 5 to the power of x, we can see again we have no x-intercepts. Again, the y-intercept is difficult to see because of the scale, but it is at 2 this time. The end behavior is actually the same. It goes from quadrant 2 into quadrant 1. The domain is also all real numbers. And the range again is y is greater than 0. So we can see a number of similarities. The only difference is the y-intercept. And the y-intercept is different because of the presence of a in this function. It's a 2. That will actually dictate the location of the y-intercept. So I'm just going to flip to the other two on that slide. I have the full table here. We've already filled in the first two columns for the first two functions. Now we'll look at the second two. H of x equals 1/2 to the x. Well, again, we can see that we will have no x-intercepts because of that asymptote. The y-intercept is easy to see here. It is at 1. And we could have determined that because we do not have the presence of an a, so a must be 1. End behavior again goes from quadrant 2 to quadrant 1. The domain, even though it's moving down as we go left to right, it is still all real numbers. And the range again is y is greater than 0. Looking at j, again, no x-intercepts. Y-intercept is difficult to see because of the scale of the graph, but if we look at the equation, we can see that a is 8, so our y-intercept would have to be 8. Again, going quadrant 2 into quadrant 1. Domain is all real numbers. And the range again, y is greater than 0. So in fact, no matter what we do to these functions, at least in the way that we'll be studying them, only two things will change. That is the value of the y-intercept, which is dependent on a, and the actual shape of the graph. If I flip back to these first two go up as we go left to right. Those are called increasing functions. These last two go down as we go left to right. Those are called decreasing functions. And that is a consequence of the value of a. So when we have, in these first two, 10 to the power of x, sorry, I said that's a consequence of a. It's actually a consequence of b. I misspoke there. B is 10, b is 5. So what we know is that if a is greater than 1, in fact, we have an increasing exponential function. So if b, please ignore all those a's. I was just saying if b is greater than 1. Likewise, in these last two, we have b is a half and b is a quarter. So if b is less than 1, we have a decreasing function. Now, we're not going to talk about the situations where b is a negative. We're only going to deal with positives. So technically, b would have to be between 0 and 1. But if we have a number greater than 1 for b, increasing, we have a number less than 1, decreasing.